It does force you to remember certain things. Remember we talked a little about this yesterday. Yes, ma'am?
Does that mean like 3 inches for each thing? Or
Yes.
like 9 inches total? Okay.
Yeah. What's happening here is I'm going to ask, what's the probability of scoring 5 points? Notice how it says 10, 5, 2, and 0?
Yeah.
So I want to know what's the probability of getting 5 points, which means I need to find the probability of that greenish circle. Okay? When we talked about that yesterday, when we're dealing with geometric probability, it's still going to wind up being the area of the favorable region divided by the total area. Okay? Now, the total area is the easy one, because what's the biggest shape here?
Square.
It's a square. What's the side length of the square?
18.
It's going to be 6.
6?
6.
Oh.
Take a look. Because this is going all the way out here, which means it would be going all the way out here, which gives you a side length of 6.
Oh, I thought it was 3 for each one, and then you had to like make it 18.
Oh, I'm sorry. The whole thing. Yeah.
I was just asking.
I'm sorry. I just looked at the. Okay.
Oh.
Sue me.
I will.
Yeah. I thought that was saying that whole line was 3.
Yes, it's 18.
Okay.
Alright.
I have good intentions of being decent at this job. Believe me.
Oh, it's
Really?
Wait, what? A bar?
No.
Like, what's that?
My children woke up in the thunderstorms last night, so they kept us. And then my dog was screaming. Yes, ma'am.
Did either of them wake up and take a shower at 2 a.m.?
No. No, but I have caught my children sleepwalking before. It's kind of funny. So if the side length is 18, what's the area of the square?
18 times 18.
All right. So the area of the square here is 324 square inches. Now to figure out the area of the 5-point circle, we have to identify. Well, we got to find the area. Well, this area, to get this guy, you have to take the whole circle and subtract out the one in the middle. Okay? It's the donut hole problem. So this one has the circle here has a radius of, I'm going to try and get this right, 6. Thank you.
You're welcome.
So it has a radius of 6. That gives you an area of 36 pi. But you got to back out how much? 9 pi. So the area then of the green would be how much?
27.
25.
27.
27.
Oh.
You're right.
Yeah, I know.
Now you have to be careful when you type in your calculator. Use the fraction bar, type it in, that'll give you your total. That'll give you your probability. Hopefully.
27.
Say if it said, what are your chances of getting 10? But you could make as many shots as you
324.
wanted. Would that like?
It'll be, because then each shot is
26.179938878%.
So like say if it was like what are all
Let me
the
come back, let
combinations?
me get back to you in 1 second.
Oh.
Hold on, what was it again?
26.179938878%.
Oh, so 0.27?
Yeah. I mean, I wanted to make it percent.
It's like the way you said it was.
Yeah.
Can you put it in your thing? Because percent.
Because it looks
because it's probability.
cooler.
Yeah, your chances of doing.
Keep it simple, stupid.
All you do is
I give the kiss method.
like it's not like making it into percentage.
I know, there's no need to. There's no need. If it makes you feel good. Now, what you were asking a second ago was, what was the probability if you kept trying to get the bullseye each time?
No, not that. What is, like, say, you could hit any spot, but it would, you want it to equal 10. So you could hit 5 twice, or you could hit 2 5 times. But like, how would the probability, like,
Oh,
Yeah,
okay,
like
that's
that.
weird. I'm not sure on that one.
That's hard. I'm not doing that one.
like I'm
So
assuming
how many
it'd be
different,
very
how many different combinations are there to have a sum of 10?
Yeah,
I still think you have to know how many,
shot, like how many
Yeah.
shots are on? Shots.
yeah. Because you have to take at least, at most you can take 5.
Yeah. Well, you
You'd
can
have
hit
to-
0.
Because like each
Yeah,
it's
and you
not
can-
a 10 a shot.
Yeah.
See what I'm saying? Now, there is another question I could ask you, and it kind of goes along with that. If I take this, what's the probability of getting bullseye 2 times in a row? Can you multiply that? Why?
13.
Correct.
That's like the event.
They're, each one of them is independent. I thought that's where you were going.
So you multiply the fraction of the.
Yeah.
I would
Say, Jared,
Whichever one. Think, anybody got a quarter?
What was the correct answer?
Oh, and a quarter, right?
Jeez. I don't like change. I don't eat
This
it.
is a
Oh,
scam.
man, I
This is
got
not a
it.
scam. It's like, I'll give it back.
It's like, all right, what state is it?
Wyoming.
They're all
Wyoming.
Alright, and this problem?
Heads and tails, right? You flip it, you got 50-50 chance.
Yeah.
Now, this kind of goes into what we're going to talk about more tomorrow, compounding events. The probability of getting tails, tails. Well, what's the probability of getting tails the first time?
50.
Does the fact that I flipped the coin again have any relation to the tails that just got flipped over? It doesn't. It has no relation to it whatsoever. Each trial is its own independent event. So therefore, you use that multiplication property. So the probability of getting 2 tails in a row is what? 1/4. 3 tails in a row would be
8.
4 tails in a row,
116.
and so on and so forth.
132nd.
Okay.
164.
So-
128. 126.
Let's go.
You should have quit while you were ahead. We tried our best to duplicate that, not even close. So if I flip it over, I want to get tails, tails.
Heads.
Tails!
Tails never fails.
False.
Oh. Heads.
Oh.
So I did win. But that's the idea. Oh, I want you. I'm going to think about it. Okay, you do this? You guys do this?
Well.
Whoa, right here.
We do it again. Do it again.
You've never done that before?
My stephouse bruised my finger by doing that once because I went to catch it.
I always try to catch
Thanks, sir.
Like,
Caleb, heads up.
how do you do that?
Bounced off and.
Wow. Wait, do it again.
One more time.
Do you hear it going by?
Yeah.
Yep.
Oh, I can.
Whoa.
Oh!
That kind of hurts.
Yeah. That's weird. That's so cool.
Nice catch, Aaron.
Oh, DJ.
So yes, there you go. I try. Teach you something new. I can also speak English every once in a while.
Wait, he's like.
There we go. Thank you, DJ.
Yes, ma'am.
So the answer to getting 2 goals are 0.
Oh, sorry. Yeah, it's back to that. So if I want to look at the probability of getting a bullseye here, the probability of getting a bullseye would be 9 pi over, what was it, 324?
Yeah.
So 9 pi over 324 times 9 pi over 324. Well, let's get some,
I don't know how to do it.
when you multiply it out, let me steal your calculator if you don't mind.
That's cool.
I do apologize for showing you guys that, because that's all you want to do now.
I'm coming for this. Just a minute.
I should put parentheses around just squaring it, that would make more sense.
You said less than
002.
So I get a point,
76%.
the probability of getting bullseye twice, back to back, is less than 1%.
And it equals 3 times you cube.
Yeah, it's just, because each one of those tosses is
You're
independent
gonna
of
see about
itself.
10 times in a row. I'm about to
Wait,
get this
Mr. Murphy, I'm
turkey
confused, because like,
eaten them.
turkey, when I said
Yeah, like bowling.
What's 5 times 5?
okay.
Pi squared. Okay. And you get the right. So if you did that, if you just put it in parentheses and squared, it'll work. Okay. Does that make sense, guys? That's how that would work. So each trial, if it's independent of itself, you'd have to multiply the other. That's some of the compounding things.
2.5, 6, 1, 2, 6, 2, 6, e to the negative 11.
Let's find the probability of landing in the shaded region.
You could say that.
But it's not regular, so that's not going to help with anything.
Would you want to create a square?
Why would you even use
What?
an hexagon? You gotta use the rectangle one, and you gotta use the two.
I don't know if the square is going to help you with anything.
What square?
If you fill in the outsides, it make a square.
Oh.
No, does it say that?
You don't know that.
Does it say that we have? It just says we have a 2 isosceles triangles.
And then you got that little rectangle in the middle.
Right. That is. I'll give you that. That is a rectangle there. So we need to work on how do we set this up.
Wait, isn't this
Oh,
geometry?
No.
This is a geometry problem.
square area.
There's no.
Add the three areas.
That's a rectangle.
Rectangle.
There's no
Add
square.
areas together, and then
Yeah.
We know that the rectangle in the middle is 12 by 4. So the area here is 48. We know that for the non-shaded region. Okay.
Wait, are we looking for the,
Shade. I want to do geometric probability of shaded.
okay,
Okay.
so we can try.
So I want the shaded.
You have to draw in a side or something.
What we're told.
no, bro.
Why would you could? Because then it would be 6.
Well, if you look at it, you have a
Bless you.
base of an isosceles triangle, which is 12. I've said this 4 times. There's no square. Do we see right angles here or here? No, you cannot assume it's a square because you make an angle side side. How do you mean?
Oh.
What's that? A lot of times, yes. But remember, properties.
Sine.
There's law of sines and stuff like that. But if you have an isosceles triangle, if you draw in the vertical height, what does it do to the base?
Oh, the base is a right triangle, and it cuts it in half.
So now you can get the overall height of the triangle. How would you figure that out?
12.
Pythagorean theorem. We have 64 minus 36 and take the square root. Was it 18? No, wait, what is that? It's 28, excuse me.
Yeah,
So it's 2 root 7 is your height.
Wait. I'm lost. Oh, 64 minus
I'm following you.
30.
Whenever you have, one of the properties of an isosceles triangle was that if you drew the height from the vertex between the congruent sides to the base, it's always the perpendicular bisector of the base. So I created a 6, I don't know what the height is, but the hypotenuse was 8. Pythagorean theorem gave me the hypotenuse. Okay. It was the square root of 28, which is 2 root 7. Yes, sir?
Does it have to be 2 root 7 or can it be a decimal?
It's not the end of the world, to be honest with you, because you're winding up with decimal when you're done. I usually write things in roots if I can, just because it's cleaner. It's less rounding error, if you look at it that way. So the other thing is, I want you to see that you have 2 identical triangles. You okay with that? What's the area of a triangle? 1/2 base times height. Well, now you know that it's going to be 2 of the 1/2 12 by 2 root 7.
Kids allowed.
Yeah, so the 2.5 drop out. You okay with that?
Yeah.
To that, we have to add the 48 to get the total area. The areas of the shaded region was just this. So there's little properties of things that are still thrown at you from time to time to get you that. Okay? Yes, sir.
So the plus 48, you don't put those.
Not in the numerator, but that goes in the denominator, you get the total area. So your numerator would be this. The denominator would be the 2, 1/2, 12, 2 root 7, plus 48.
You still need to put the 2.5 thing you.
No, not at all. I'm just showing you, without writing that out. If I didn't write that down, someone would say, what happened to it?
Ah,
What is the answer? I'm going to check it right now. 24, oops. 24 root 7 over 24 root 7 plus 48. Oops, syntax error. I do too.
I got it. 57.
Funny, I got negative 2 root 7 plus 7 all over 3,
Something.
I got 0.569.
which is 0.569499. You got it right.
Wait, so should we put it in terms of decimals or just like try to find the
This calculator does it.
Pick what you want.
Decimals are fine. I was just harassing. You didn't get that? What'd you type? I just typed it in. Yeah, throw parentheses in the denominator. Or use the fraction bar. Use the fraction bar and that would have worked. Okay? So you have stuff like that. Show you another one.
You're the one with the whatever it's called.
Pretty sure I remember this.
Did we not do this one yesterday or?
No. We did something similar to it. Geometric probability of landing in the shaded region.
Oh, I remember doing that.
No.
Very was
So we know that the large shape is the circle. You okay with that? And that's easy to figure out. It's going to be 49 pi. To get the shaded region, we have to take the 49 pi, subtract the area of the hexagon. Well, if it's inscribed in a circle, that means it's a regular hexagon, which means we have to subtract the 1/2 perimeter apical. And what are we going to divide all that by? 49 pi again. Now let's see what you remember about a hexagon. Hexagon was a special figure when it dealt with being regular. When it was a regular hexagon, you knew that all the sides were the same and all the angles were the same. I don't know if you remember this, but do you remember how to find the measure of each of these interior angles?
You cut it in half and it makes it like.
N minus 2 times 180 over n. It's convenient that I left that up from geometry today.
Just remember that just perfect.
Right. So what happens here is that you get all these base angles are 120 degrees. After that, yes sir?
Is n number of sides?
Yes. After that, when you draw on the radius, what you should remember is that these are all, you get all these isosceles, but it also bisects these angles, which means that all of your sides are still all 7s.
42 is the prime number.
So there's lots of them. So what happens is, in a regular hexagon, you get 6 equilateral triangles. It happens every time. No matter what the side lengths are, you will always get 6 equilateral triangles inside of a hexagon. So if you knew the radius, you know your side lengths, because they're always going to be the same. So what's the perimeter then?
42.
42. We know the perimeter is going to be 42, so we have 49 pi minus 1/2 of 42. But we still have to figure out this apothem thing. Remember, I did this a little bit differently than other teachers when you draw these up. I always drew that little picture. Because no matter what regular polygon you have, you're always going to have 3 sides connected to each other somewhere. You're always going to have 2 angles, one of which we can draw a radius into. No matter what, it always happens. I know that the angle was 120 for the large one. The bisected angle was 60. Now look at what happened to that right triangle in there. What type is it?
30, 60,
So what's the height, or what's the apple?
3.5,
Yep, root 3. So your apothem is 3.5 root 3. Oops. So this is just a little refresher in some old stuff today, because it still shows up. Okay? There's geometric probabilities. They still use this quite often. Okay? When you put that in your calculator, just be careful how you type it in, put parentheses. Use the fraction bar. It'll work if you type it in cleanly with parentheses and stuff. Let's see. I think this calculator would be faster than did you not have extra parentheses up top?
no, I didn't.
That's what I've been trying to fix. It's kind of like hard to get it to do it.
5.17. Should be 0.17, I think. I'm sorry, type it.
I think I might mess up.
I didn't do the extra details.
Oh, here's why. You took the answer, you divided by 49, then you multiplied it by pi. Here's, you have to do this.
That's what I did.
You have to put it, whenever you have divided by 49 pi, you put parentheses. Well, you still have to.
I didn't do the extra.
I got it.
Yeah. Put it in with the, you guys, use that fraction bar. Use the fraction bar.
Score! So would you leave it at 0.17?
Yeah. Yep, I'd say it's point, my answer is 0.17.
That's so weird how it's just parentheses that you got.
Yeah, and that's why when I write these things out, I write it out really basic. So if you type it in the way that I wrote it, you should be right. Now, when it comes to doing this on your homework or doing it, especially on a quiz coming up here, write it out before you type it in. So Izzy, let's say you had it written out like that, but you gave me your answer of whatever it was, like 0.001. And then I would know to put a big giant frowny face on you and ask if your thumbs were broken.
Oh, I know what I did.
Yeah, I had a weird vibe.
I would feel bad for that statement then. But I'd get over it, and I'd give the thumbs up.
And you can tell that the
I'd say,
well, you could tell us the way of the
what's that?
I think I usually don't.
I'd be all right. Quick question. What kind of motorcycle did Fonzie drive?
Fonzie, like Alonzo?
Arthur Fonzarelli. What kind of motorcycle did he have?
The cool one. A Harley.
Nope. Nope. Nope.
What the?
Get a Triumph. Get an old Triumph.
I was close.
No, you didn't.
Yeah, what?
I'm trying.
I don't know, man. I got it right behind.
Wow, they're doubly going crazy today.
Maybe
It's an
now.
actual twister.
I have a feeling they would have said something by now.
I like
Well, so Twisters are never happening during the morning.
Probability non-shaded.
Oh, mixing it up.
Mixing it up. Because I'm whack.
So,
So you're the non-shaded, not.
I want to do the non-shaded this time. The unshaded. Probability of landing in the unshaded region.
I don't like.
Whoa, that's gonna be so different.
4
It's going inside out.
Mine sucks. 4 is the diameter.
So that means you have radii.
Should be 4, 5.
So it's 12 by 8 minus, we have what, 4 pi, so we have 1 little, 2 little, 3 little circles, 4 little, 5 little, 6 little circles.
Oh, crap.
I'm trying to find the probability of the unshaded region.
Can I use something calculator?
Yes, that's exactly what it is. Yes, Izzy, that's what I do.
Okay.
What did you get then?
0.214601.
You say fall?
Okay. Why is it so funny? Oh, alright. That's what I got.
It took a while for me to realize that I did that. Yes, sir. You found what's called the complement, and that's fine. Absolutely fine. Ah, I see what you did there. I got a couple. I don't want to do all this because some of this has some linear stuff on it that we need to worry about. Let me give you the numbers here. Let's do this.
Oh,
You don't get the joke then.
I got I don't even know if she understands. Yes.
Let's do that.
There's a lot of fresh.
Okay. Let's do those. You do that separate sheet of paper so you have space.
Everybody.
All right.
That's what you said about the last one, and I said
Shouldn't be that bad. It's fine.
No.